Hello, everyone, and welcome to my presentation on the AIoT with Multi-Modal LLM platform for this company. Now, we will be looking at a couple of things, the AIoT system architecture, the VMS, the Deep Cloud AI, AI Craft, and the Multi-Modal LLM. Of course, you might not understand what some of these terms mean, but don't worry. We will explain them as soon as we get to them. For now, you just need to know that this is a general order we'll be approaching things in. So first we look at the AIoT system architecture. Now, what is AIoT, you might ask? The AIoT is the AI IoT, where you already should hopefully know what an AI is. It's an artificial intelligence system. And IoT, of course, is Internet of Things, where we have various things, in this case, primarily cameras, connected to each other, and in this case, to a central cloud. So for our system architecture, we have local clients here, represented here as computer monitors, as well as remotely managed PoE switches at each location. Now each location here, which you can see is being merged into a central cloud, can be an individual store, and there are sort of like two configurations for each store. Each store or location has video recording through its own cameras. And in the first configuration, here labeled as server configuration 1, we have a x86 VMS running a video sense VMS local node, as well as a x86 AIoT box running a tiny cam container, separately yet connected to each other. In server configuration 2, the x86 AIoT box runs both the VMS local node and a tiny cam container. Now the VMS here we have is a video management system, and the AI and the TOI cam is a tinker it yourself camera container. And overall, all of these together merge their data into a central cloud here, where we're running the deep cloud, the video sense central node, and IPSAN. IPSAN is our IP storage area network. We're not just referring to Mr. IP here. And overall, this cloud can be accessed through a control room, like a physical monitor control room setup with all the screens, or a mobile client. We'll get to that later. For now, let's look at Deep Cloud AI. Our Deep Cloud system consists of 4 layers. At the bottom, we have our front-end devices, which is our cameras, our signage with our cameras, our speakers, mics, sensors, actuator, and of course our TIY cam setup, all that stuff. We have a second optional layer, which is our edge platform, which may have like IoT platforms for the existing sensors, and AI box. This step is optional and can be switched, but no matter what, we have a third layer, this green stuff, which is the service we're selling. In the service we're selling, we have our data connection with its various features here. Device MGM, or device management. We have a data lake for storing our data. We have a data cache for caching it, video management, AI craft, AI cluster dispatcher, a data search, and an API. All in all, it's our AI and video service. And finally, we have the top level application, which is used by our users, which includes our mobile app, our dashboard, alert system, and our system content management. You might wonder what the yellow is, and the yellow is stuff that developers can sort of build themselves that we provide the tools of. These mostly include our AI craft and TIY cam. For our IoT subsystem, we have our devices, which includes such things as our cameras over here, and our other sensors over here. Our cameras access a video subsystem, which through a P2P web plugin can sort of like directly stream their feed to a video device here. They can also go to the IoT platform where their data can be processed and sent through the WebSocket API to our applications. as well. So let's look at the effects of our platform, shall we? Before we have the wall of shame, which is well, they're just pictures taken by our security cameras on a physical wall. There is not much to it. It's a literal wall of shame. But after that, we have a security company alert terminals, which can alert people, which can alert our security to a person's presence. We also have app alerts and a database for our system, which is shared, our database of pictures and other things, which is shared across the entire system. So whereas earlier you might need like mail pictures to other stores, here you can just have it automatically sent to all other locations. Some of our highlights include face clustering to show the trajectory of a person in a location. We can track a person's movement in a store. Night vision, so you can still see where a person is at day and at night, and our system can still recognize it's the same person even though the time has changed. Gun detection, where it can detect the presence of a gun in the video. As you can see here, it is able to detect that there is a guy holding a gun. License plate recognition, which is fairly self-explanatory. It recognizes license plates. And next we have VMS. Our VMS architecture works for having a gateway and camera NVL and other low-level VMS here. Feeding data from LAN to a VMS. It can be sent to a decoder to directly stream the contents to the video wall, or it can be sent to the DIY cam container for where the data is processed. Our metadata, such as like where a person is and such, can be processed and sent over here and sent to our client, Open API in Open SDK, or to other VMS software. Some of our highlights include live preview, PTZ control, intercom, playback, scheduled and snapshot polling, and video walls. Snapshots and scheduled polling are where you control the camera, where scheduled poll involves camera panning to locations at predetermined times. The snapshot poll has multiple cameras taking pictures at the same time to construct the view. We also have a video online GIS map where you can mark the locations of your camera on an online map for quicker maintenance and other applications, as well as just tracking your cameras in general. You can also highlight your alerts quickly on the map to sort of highlight the locations of a problem if you need to on a map. Our web client is shown here where we have video feeds and devices. As you can see, we also have a recorded timeline in this case, as well as, yeah. We can also monitor devices here. We can see that both of these cameras are online in this situation, and we can also add a new device. And here's our video clients menu. You can see we have the map, event center, our live streaming, as well as other features. Our mobile client supports fairly similar features. Here we have a live stream. And our PC client is also fairly similar with its video wall and event search. You can see here that the PC non-web client is fairly similar. It can perform system maintenance, as well as upgrade packages, which is part of your system maintenance. It can also mount local storage instead of relying solely on cloud storage. And finally, we have, well, not finally, but we have AI Craft here. AI Craft goes through a process where we collect data, create a model, pack the application, market the application, and execute it. And then collect more data as the cycle goes on. Here we can generate a model by labeling data manually, configuring the model and training it, testing it, and repeating until the model is accurate enough, then you release it. Once it's released, it is converted, modeled for application on different execution hardware, such as embedded systems, packed as application, and released. As you can see here, you're bringing the device online, you're selecting application, downloading the application, executing it. Here we have an example of an edge box, an AI box for retrofitting, where existing cameras are used instead of new ones. In this case, an AI box is used to extract the information from the camera's video stream using analytics, and it can be run with or without deep cloud. For each channel of the web server, you can configure an algorithm here, such as over here, we have various channels with their devices, their streaming URLs, and their algorithm ability. So on number 1, we have a missing item algorithm, and on 4, 5, and 6, we have person real ID algorithms, where they're identifying if a person is the same person as a different person. In our AI Craft Marketplace, we have various algorithms here. Here are some of the examples, including face detection, people counting, helmet detection, spell detection, barcode reading, and defect detections. We also have a updated algorithm list at LinkSprite's github.io, which you can find in the link here. Here we can add a new channel with the algorithm. We have a device RSTP URL and algorithm ability. And now we have multimodal and finally we have multimodal LLMs for checking. So how this works is we have our video stream. We have all the stuff we had earlier, where it does all the checking and stuff to say detect a person. If our first AI bug is unsure, for example, if it's not sure if a person is the same person as someone else, as its confidence is not high enough, it will upload the data from this faster AI box to the slower cloud, where the cloud uses a bigger, more accurate, but somewhat slower LLM to check the AI box's work to see if it's correct or not. So here our AI box's work is green, and our cloud LLM's work here is orange. Our middleware essentially works through streaming our data stream to here, where it passes data to and from your terminal and overall goes through this pipeline and control hardware. Middleware essentially divides our jobs into minimum units to distribute to customer service, which is our LLM. It distributes them. Each job is distributed to 2 reps, or in this case, our bots. If the returns match, it will pass. Otherwise, the job will be distributed to a 3rd tiebreaker. And we also have metering for statistics monitoring. So for example, here we have a person real ID task here. You can see here that we have a initial annotation. We have another one for customer interactions to see which images here have interactions. Here we have just a simple yes or no question. And here we have some task management to just check how many people are involved here, how much of the task has been completed, and so on. You can also monitor the general statistics related to the double checking process. And here we also have a big dashboard that can be used to monitor traffic. We have a heat map, we have a list of visitors, we have live faces and subject notifications, as well as a general frequency of visits table, along with other things such as a history. So here we have another one here. We have customer interactions, customers and staff, and so on. And that's it for all the features of our system. Thank you for watching.